Hello guys, today I want to talk about the yellow-based directional traffic analysis using CCTV footage. I will discuss on this subject matter and show Python codes, GitHub repository and how yellow works. So, firstly, actually, I want to uh, describe the CCTV video analysis. I actually do four video working on the four video files. The first one is original CCTV footage of intersection. Then I use video annotation, which can interpret flow and speed. The third one, I use video annotated only for classified vehicle detection using supervision framework. It's a framework developed by RoboFlow. And lastly, there is a video annotation only for directional flow. But for this study, I only use the two, that is video annotated with flow and speed only. And the video data are were completely extracted using Python yellow codes. I'll discuss it uh, in detail later. So in the video annotated with flow and speed, there are 16 parameters I have extracted, and I write down the name of the those parameters. Most of those parameters are directional, and within that there are vehicle counts, speed distribution, density estimation, flow estimation, time mean speed, and space mean estimation. All these parameters, even headway distribution is calculated. Uh, so this is the recorded CCTV video. In the left side, you can see the screenshot of original video record. In the right side, I have video annotated with flow and speed. And this video annotation I use for analysis only. Next one is I annotate the video for classified vehicle detection. I use the supervision framework, which is developed by RoboFlow. And the right side, we can see the video annotated with directional flow. This code only run the directional flow only. So just leaving the PowerPoint, I want to show the video actually. If we look at the video, I want to show. This is the original video of my traffic footage. This is the original video. We can see the original video, number one. We can see an intersection and traffic is flowing in different direction. There are cars, motorcycles, buses. And whenever we use the vehicle detection only using supervision, and this is the video annotated using supervision framework by RoboFlow. I use yellow for this. Yellow is the baseline. You can see the analysis of the video. Next one, the video I use to extract the speed and density. You can see the vehicles are detected and see the speed. This is the video that I use for further analysis. And I didn't actually record the video for traffic flow only, though I have the screenshot of it. You can see the screenshot of directional flow. Now gets back to my presentation. So how actually the spot speed is measured? The spot speed is measured using a Python code. I want to show the Python code actually. Let's go to the Python code for speed and flow. This is the Python code that I write using yellow. You can see that the video path and model I use yellow 11N. Detail code are written over here. I am not going to describe each and every step of this code. These code are available in my GitHub repository. I have already shown you My GitHub repository is over here. So I want to just focus on a specific task, say how spot speed is measured in the yellow. For every video frame, I calculated the frame number and frame per second. Then yellow tracking detects vehicle and assign ID, unique ID, and center point of each vehicle bounding box is computed using yellow V11N, that is a small model. Then vehicle seen in the previous frame and pixel distance is measured, and pixel actually converted, calibrated with the meter. I have already option to measure the calibration, that is pixel per meter is measured, so we can calculate the distance traveled. So we know the distance traveled and no time step or time elapsed. So distance by time is the speed. Actually, it gives the spot speed, and detailed pseudocode is written in the left side of my presentation slide. You can see that. Next, the question comes how directional traffic counts are recorded. For each frame, calculate frame numbers and timestamp. And yellow tracking detects vehicle and ID as similar to previous one, that is speed calculated. Then center point is compared with the previous position, and movement path crossing the counting line I have drawn. You can see that there are multiple counting lines. One, two, three, four. There are four counting lines. So these counting lines, whenever cross the counting lines, it counted the vehicle and also record the pixel and converted the distance into meter as not this. Then counted the crossing is confirmed, and frame number, time, vehicle ID, and line index and movement direction are recorded. Movement direction are recorded in the list. This is the pseudocode for the directional traffic count. So this is the raw data, and raw data that extracted from yellow code, running yellow code, and I recorded this raw data into Excel. There are six columns. You can see the frame, timestamp, ID, vehicle ID, line. That is, there are 0, 1, 2, 3. There are four lines, and direction, that is up, down, right, left is considered, and speed is recorded. And you can see, I can see you this is the code that I show you already. This is the Python code developed to extract raw data from video CCTV footage. And if we look the this is the raw data. I want to show you the raw data. This is the raw data that I obtained after running the yellow code. That is frame, timestamp, ID, line, direction, and speed in kilometer is recorded. Next, if we look, I use another code actually to extract further analysis. I want to show that code. The analysis is over here, and from the raw data, I extracted further. And this is the further analysis that calculate time mean speed, space mean speed, density, headway, and other stuff from the raw data. And it actually beamed the data for every 5 seconds and plots and do a lot of plots. So one of the component of this code is time mean speed and space mean speed. I will describe how to calculate the time mean speed and space mean speed. If we look at that, the time mean speed is calculated by the arithmetic mean of the vehicle speed, and it is summing the vehicle speed divided by the number of vehicle, and our speed is the spot speed, we know, and space mean speed is the harmonic mean of the spot speed, that is number of vehicle divided by inverse of spot speed is give us the space mean speed over here, and this is the pseudocode. And another stuff, more important parameter, that is density, since it's not possible to calculate the density properly. So what we did, that we calculate the number of vehicles and observed time. And within the observed time, we have the traffic flow rate. We know the traffic flow rate here, and space mean, corresponding space mean speed is calculated just one slide ago. I have shown you, and we know the traffic flow rate and space mean speed. So traffic flow rate divided by space mean speed will give us the traffic density, though it's not possible to calculate direct density since our road space is little bit small, and there is a way to calculate directly is density from using YOLO, or we can use ROI, that is region of interest. But in this case, there are directional traffic. We look at the picture, there are directional traffic. So it's not possible actually. It's not possible to calculate density directly. So we calculate the space mean speed and calculate the flow rate, and dividing flow rate divided by space mean speed give us the density in each direction. And this is the analytic data, 5-second aggregated traffic data. We can see that for every second, every ID, line, direction, speed, and pin number is recorded, and the data is then binned from every 5 second, aggregate vehicle count, time mean speed, space mean speed, time mean speed, density, and speed, density, and the flow rate. We can see that. And if we look at the output graphs, I want to show actually the Excel files of analysis, that is 5-second directional analysis. We have 5-second directional aggregate. This is the raw data, and assigning the bin, 5-second directional aggregate, 5-second flow matrix, directional flow matrix. We have traffic flow summary. The values I have vehicle, time span, time mean speed, space mean speed, time mean speed, space mean speed ratio, density, and other stuffs. This is the count pivot, speed status, summary status, max speed, mean speed, median speed. All details are given over here. And if we go back to the plots, graphical plots, we have the different types of, so 16 different types of analysis. I'm showing it in the PowerPoint slide. Firstly, we have directional vehicle count and direction-wise average speed with respect to time. We can see that. Then directional traffic count distribution for each 4 direction, and direction-wise speed distribution. I have provided the box plot here. We can see that outliers also, median, quartile speeds, and cumulative vehicle histogram, vehicle speed histogram. We can see speed distribution. We can also see also total vehicle count over time. We can see speed over time, and average speed standard deviation is showing with its variability. We can see the comparison of time mean speed, space mean speed, speed density over time. And we can see the fundamental diagram, that is flow versus density and speed versus density, density plots, but curve is not drawn over here. Just a scatter plot are given. And we can see the directional time mean speed, space mean speed. And on the right side, we can see directional density distribution for 4 directions. And next, the directional flow rate, we can see that the flow rate versus direction, different direction, and headway distribution we can see. And that's all about my presentation regarding I just want to re-show you the annotated video that extracted using YOLO. You can see that the video. And that's it all about my presentation. And thank you so much for watching my video.